Okay, this is part 2 of a series on 2D motion, and we're looking at finding components of vectors. So this is going to be becoming either side. We're going to break this down into its x component or its y component, and here's one sample problem. Find the west component of 135 meters, 26 degrees west of south. The best way to do this, simplest way to think about this is if you walk it backwards, draw the baseline first. So go south first. After that, you're going 26 degrees to the west of it. So next thing you'll do is just do the second. So walk it backwards, went south first, then we went west. And then we needed a place to put this 26 degrees. So we're going to draw the resultant. Resultant is nothing more than what you can do instead of these two directions. Throw the 26 in there closest to the origin dot. And what we were describing was the 135 meters where it was. So the last thing we do is we put that will always be in the hypotenuse if it's tied to an angle. If it's next to an angle, that's going to be the hypotenuse every single time. So now we need to determine, okay, what are we trying to find? We're trying to find the west component. So you look at which arrow you drew that is west. And that's the arrow right there that's drawn west. There's only one arrow. And we notice that that's going to be this 26 degrees opens up to it. So this is your opposite. And the longest side was your hypotenuse, so 135. So having a hypotenuse, having an opposite, once again, we're not concerned with this one. So hypotenuse and opposite, this is going to lead you to using sine. And when you use sine, we're trying to solve for opposite. It's in the numerator, so we can just go ahead and multiply out the hypotenuse. And we're left with opposite equals the hypotenuse, which is 135, times sine of the 26 degree angle. And that answer is going to be 59.2 meters west. Okay, you're taking the same example, but solving now for the south component. You just draw it again, go south, because that's the last thing we see, then go west, then draw in the resultant. Now we have a place to put this angle, and now we have this that always goes on the hypotenuse, the way it's worded. And now we're looking for our south component. There's only one arrow that's drawn in a southward direction right here, and that is our adjacent side, because it's not the opposite, it's not the hypotenuse, but we are going to need the hypotenuse. It's the number we have. So we have our adjacent, we have our hypotenuse, and we're not running off the last equation. We're just starting it fresh, so let's pretend like we don't know our opposite. So we're just using the adjacent hypotenuse, and that is going to lead you to cosine. You have adjacent, you have hypotenuse, and you do the same math. Multiply out the hypotenuse, cancels out. Adjacent equals the hypotenuse, which is 135, times cosine of 26. And we type that into the calculator. That ends up being 135 times cosine 26 equals, that ends up being 121.3 meters per, just meters, and then south.